just to recall, in viscoelastic behavior, we discussed in the previous lecture two models, okay, that will characterize the viscoelastic models of or viscoelastic behavior of these materials. And these are the Kelvin-Voigt model and the Maxwell model. So the final equation that we obtain for the Kelvin-Voigt is this one. This is in terms of the retardation time, tau sub c. Okay, and remember that the reciprocal of the retardation time is just your rate of relaxation, and the retardation time is just viscosity over the modulus of elasticity. Kelvin-Voigt model is normally used for viscoelastic materials that are more solid rather than fluid. Okay, hence you can use this equation. While for Maxwell, it's normally for materials that are more fluid rather than solid, and so you can arrive at this equation right here. Okay, so let's solve some problems related to viscoelastic models. In a creep test, a viscoelastic material with modulus elasticity of 600 megapascals is initially loaded with a stress of sigma sub 0, okay, at 20 degrees Celsius. Half an hour later, the strain in the material is measured to be 0.111, and another hour later, it's found to be 0.264. What will be the strain in the material 3 hours after the initial loading? And how much time did it take for the strain to reach a value of 0.001? Okay. So we have here some given values, and we're after solving the strain after a certain time, okay, and the time to reach a certain strain. So there are two requirements in this problem. Okay, so how do we approach this problem? What we're going to do is okay. So sabi dyan, creep test, right? Okay. Creep test. So pag creep test, ang ginagawa is that meron kang stress, okay? Apply the stress and then hold it constant, okay, for a certain period of time. In doing so, you are now measuring the resulting strain, okay? And then you will release the stress. What will happen also to the strain? So anong gagamitin nating equation? So since it's a creep test, okay, we will use the Kelvin-Voigt model. Okay, the Kelvin-Voigt model. So this is the equation. Okay, so if we're going to use this equation, okay, we need, of course, yung time na given, tsaka yung strain as a function of time. Okay, so using that equation, we will arrive at these relationships. Okay? So ito yung strain as a function of time, ito yung time. Then ito yung retardation time. That will be called equation 1. Okay? Yung initial stress is unknown. Okay? Hindi siya given. So we'll leave it like that. And then yung 600 megapascal, okay? So ano ba siya? Siya yung E, right? E is 600 megapascal. So we have two unknowns, right? The retardation time constant, tau sub c, and the initial stress. So we need another equation, and that is this, because given naman yung strain at time 1.5 hours. Okay? Kasi diba, half an hour later, 0.111 yung strain. And then another hour, 0.264. So that's 1.5 hours total. So we have two equations and then two unknowns. So we will be able to solve the two unknowns. Okay. How? Maybe we can divide these two equations to get rid, okay, of this. No? Pag dinivide natin ganyan, mawala to, mawala to. So ito na natitira. And so you have now one unknown. And if you're going to solve, you can even use your calculators doing shift solve. Okay. You will find that the retardation time constant is 1.97 hours. Okay. So what do we do? Since we know this time constant already, you can use either equation 1 or equation 2 to get the initial stress, sigma sub 0. So doing that, okay, you will find that the initial stress is 297.2 megapascal. So in other words, we have now the initial stress, okay, and the retardation time constant. Since mayroon na tayong equation na ganon, okay, we can now develop the working equation or the expression for the creep response. Ito yung, again, equation for the Kelvin-Voigt model. But since we know now this sigma sub 0, yung initial stress, and yung tau sub c, substitute na natin sila. Okay? So, we have now this expression. So, dun sa given sa tanong, sa problem, okay, find daw yung strain after 3 hours. So, all you have to do is substitute 3 hours dun sa t, okay, and you will get the strain. And the answer is 0.39. And then yung second question sa problem, gaano katagal if the strain is 0.001? So, just substitute that. Strain is 0.001, you need to find t. So t therefore will be what? 0.00398 hours or 14.3 seconds. So ganun lang. Now let's say in the previous problem, let's say that the retardation time is 1.02 hours. Kanina, about retardation time, 1.97. Ngayon, 1.02 nung ininit mo yung material up to 40 degrees Celsius. So when you heated the material to 40 degrees Celsius, the retardation time is now 1.02 hours from the previous 1.97. The question here is that what is the creep activation energy? Okay. So we are going to use Arrhenius law here. So remember from Arrhenius equation, if you know the retardation time, okay, at a given temperature, you'll be able to get the second retardation time at the second given temperature. So just have to plug in the values here. So T sub 2 is 1.02, sorry, it's tau sub 2, and then tau sub 1 is 1.97. So si activation energy na lang ang unknown natin. R is 8.314, and of course you have here the temperatures in absolute values, okay? And therefore, you will get the activation energy as 25,094 joules per mole. So this should be joules per mole. Okay. So that's basically for creep test. And if you're given a problem which involves stress relaxation, then a good model that you can use is the Maxwell model. Okay. And aside from these two models, there are other models, okay, that account for viscoelastic behavior. Okay, but these two are just the basic ones, and it's sufficient for this course to understand at least these two basic theories.